Hi guys, today we're going to learn about another transformation of a function, and it's actually quadratics. So we've talked about quadratics, we've talked a great deal about them, learning all about quadratics, and now we're going to kind of look at them from a different perspective, from the idea of what we were doing with the absolute value and the square root functions, which is translating or transforming also the parent function. So if you look at the most basic quadratic function, it's y equals x squared. That's the most basic parent function. And we're going to actually graph this without any table or axis of symmetry or vertex. The parent function y equals x squared will always have its vertex at the origin. And we're going to follow what we call the 1, 3, 5 rule. The 1, 3, 5 rule says that I count over to the right one, up 1. Then from that point, right 1, up 3. Then from that point to the right one, up 5. 1, 2, 3, 4, 5. And I do that in both directions. Over 1, up 1, over 1, up 3, over 1, up 5. So it's over 1, up 1, over 1, up 3, over 1, up 5. And it's from each previous point. And you would continue, like you could go from, if you had more space, you would then go over 1, up 7. And it goes by odd numbers. And that's how you graph the most basic quadratic function. This is the same exact function, the same graph that you would get if you found axis of symmetry and the vertex and then did a table. You would get these exact points. So this is y equals x squared. Okay, so the axis of symmetry, just to like review, axis of symmetry is x equals 0 because it's on top of the y-axis. Your vertex is at 0, 0. Okay, so again, from each previous point. So once you get to these points, you go from there over 1, up 3. And once you get to those points, you go from there over 1, up 5. And so we're going to look at transforming this parent function. So if you look at example 2, you have y equals x squared plus 1. So this, when there's 1 adding on the outside of the x squared, this is taking you up 1. This is a shift or a translation up 1 unit. So you're going to go up 1. That's your vertex now. Now from there you follow the 1, 3, 5 rule. Over 1, up 1 in both directions. Over 1 from that last point, up 3. 1, 2, 3. That takes you here. And then from there over 1, up 5. 1, 2, 3, 4, 5. And if you could keep going, you go 7, 9, all the odd numbers. And this is the graph y equals x squared plus 1. You'll notice that you could see that it's just shifted up 1 unit, like it just moved up 1. It's like a slide. It was slid up 1 unit. So looking at this one's going to take you down 4. So you're going to go down 4, 1, 2, 3, 4. Your vertex is now here, and the width of the graph is over 1, up 1, over 1, up 3, over 1, up 5, 1, 2, 3, 4, 5. I don't think I have room to go over 1, up 7, but you could see it's like somebody took that initial parabola and they just slid it down 4 units. Now, if you have, as an example 4, a number that is being added or subtracted inside of the parentheses, so it's x plus 3 parentheses squared. So it's a quadratic, you could see, because you have the squared, but they're adding 3 to the x. So if it's adding or subtracting inside, it's going to shift you left and right. And just like absolute value functions and just like square root functions, if it's inside of the parentheses, it's going to take you to the opposite of what you would expect. This is going to shift you left 3 units. So we're going to go 1, 2, 3 to the left, and then my parabola goes from there. Over 1, up 1, over 1, up 3, 1, 2, 3, over 1, up 5, 1, 2, 3, 4, 5. And there's your parabola. Okay, y equals x plus 3 squared. And then The next one is going to take you, oh, it's the same thing. Oh, no, it's x minus 3 squared. So if you have x minus 3 squared, this is going to take you to the right 3 units. So you're going to go 1, 2, 3, and then from there over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5. And there is my parabola. So, as a kind of recap, if you have a number adding to the x squared, this is shifting you up h units. This one is shifting you down h units. If you're adding or subtracting in the parentheses that's being squared, this is a shift taking you to the left k units. That's a t, sorry. Left k units. And if it's minus in the parentheses, this is a shift to the right k units. So now you're going to see combinations of all of these left, up, down, left, right. So if you look at example 6, this is shifting you, the minus 5 is taking you to the right 5, and the plus 2 is taking you up 2. So I'm going to go 1, 2, 3, 4, 5 right, and up 2. There's my vertex. From there I go over 1 up 1. From there I go over 1 up 3. And if I have room, I go 5, but I don't have any room. There's my graph. Y equals x minus 5 squared plus 2. Okay, so in another example, example 7, and you pause me at any moment so that you could then do this on your own and check. This is going to take you left 2 units and then up 4. So left 2, up 1, 2, 3, 4, over 1 up 1, over 1 up 1, 2, 3, and that's all we have room for. Now, I'm not going to expect you guys to do these, but just so you know what happens, when the coefficient outside of the parentheses becomes something other than 1. So if this is your a value. If you remember a from quadratics, when we have ax squared plus bx plus c, this a value, if it's positive, the parabola opens up. If it's negative, the parabola opens down. The same thing happens here. Since the 2 is positive, or if you go back to the examples that we did before, since these were invisible ones and they were positive, the parabola opens up. If there should be a negative in front of the parentheses, a negative 1, which would actually just appear like this would make your parabola open down. Okay, I would expect you to be able to graph that. I'll show you one in a few seconds, but if it's positive, it opens up. Now, if the coefficient is something other than 1, you don't have to know how to graph these, but you should know what's going to happen to the graph. So remember, as the a value gets bigger, as the absolute value of a gets larger, the parabola becomes more narrow. Okay, so as the absolute value of a gets larger, the parabola becomes more narrow. When it becomes more narrow, it's called a vertical stretch. So you do need to know that word. You don't need to know how to graph it, because what's going to happen is the 1, 3, 5 rule is going to change a little bit, and it's going to become over 1 instead of up 1. It'll become up 2. And then instead of over 1 up 3, it'll become over 1 up 6. But you don't need to know how to do that. So I'm putting an X through the graph. You don't need to know how to do it, but you do need to know what happens to the graph. It's going to become more narrow. It's going to be a vertical stretch. Okay, if you look at example 9, same thing. This is shifting you up 2 units. And this is going to be, the a value got larger, so this is going to be a vertical stretch. Okay, because the parabola is going to become more narrow. If you look at example 10, there's a negative on the outside here. So that's going to make your parabola open down. So you should be able to graph this one. It's going to take you left 1 unit and down 3. So I'm going to go left 1, down 1, 2, 3. And this time I'm going to go over 1, down 1, because I want to make the parabola open down. And then from there, over 1, down 1, 2, 3. Over 1, down 1, 2, 3. And so my parabola is going to look like this. Okay. And let's see. If the A value out in the front here is 1/2, then as the absolute value of A gets smaller, your parabola is going to get wider. This is going to make a wider parabola. And remember, when it gets wider, it's called a vertical shrink. Think of like smushing a piece of cake and it from the top, and it smushes out and gets wider on the sides. Okay, and the rest of it is the same. So again, you don't have to be able to graph this, you just have to recognize what happens to it and be able to describe the transformation. All right, so you'll have some of these for homework tonight, and I will see you tomorrow. Have a nice day.